I'm going to share my learning about neutralization reactions. Okay friends, so we know that acids, base and the pH value. But what is the pH value? So pH value is in chemistry, pH value is actually defined as potential of hydrogen or power of hydrogen. Like potential or power of hydrogen is that if hydrogen increases or decreases. So it's a scale to use to specify of the acidity or basicity of a chemical solution. So friends, what we see here is that acids and bases, acidity means like the pH value is less than 7 and basicity means the pH value is more than 7. Okay friends, but we'll explain what are acids and bases. Okay friends, so what are acids? Acids. The pH value less than 7 are referred as acids. So friends, the pH value less than 7 means like, so we can also indicate that if do you know what friends? Farmers actually use the pH value to define if the soil is healthy or unhealthy for plants to grow. If it's too acidic, it's not healthy. If it's too basic, it's not healthy. But if acids and bases are the same, it's good. Okay friends? So not too much of acids or not too much of base. Okay friends? Acids are capable of donating protons. But what are protons? Protons make up atoms. So we know protons, neutrons, electrons. Proton is like in the nucleus of the atom. Okay friends. So donating protons means like losing protons. And then other atoms catch them. That's what makes them acid. Acids taste sour. Friends, I need to ask you a question. Have you ever drunk lemon juice and felt that sour tasting? Well, if you have drunk lemon juice and you have felt that sour tasting, do you know what? Lemon juice is actually an acid. Yes, friends, the lemon juice is an acid, so the lemon juice tastes sour. Okay. Bases. The pH value greater than 7 are referred as bases. Okay friends, so we saw the acids, right? The acid is like less than 7, the pH value less than 7 are acids. But for bases, you got it, that's the opposite. Okay, so for the acids we know the pH value less than 7 and then for bases pH value greater than 7. Okay friends, they are slippery to the touch. Have you ever held soap? Soap is slippery, right? Because soap are base. If you had hand soap, you just had a bar of soap, shampoos, all those are bases. And they can taste bitter. Okay. Acid and base are opposite to each other. Like we discovered the pH values are different to each other. Acid increases concentration like we learnt about in our previous videos, like increasing concentration and decreasing concentration. We all learned those, right? So the opposite is bases reduce concentration. So acid increases, bases reduces. So I need to tell you a note, friends. There are multiple types of acids and bases that we are not focusing on. Now, if you observe the left side graph, which shows how the pH value changes when we mix base with acid solution and increase or decrease base within acids. So we see the solution here, friends, right? So we'll imagine this container was a base and then the acid, few drops of acid are going into the base and the base changes its color and the pH value is increasing. So you saw that black mark is going up. So that's the thing. Friends, do you know sometimes this is increasing if we add a few drops of acid to a container of the base, right? So if we do the opposite with acid, and if it's up, the pH value is up, and if we add a bit drops of base, what do you think will happen? If you said that the pH value will go down, you're correct. Okay. We all know about all about acids, bases and pH value, right? But what is neutralization reaction? Like we discussed in our topics. Okay, friend. In chemistry, neutralization or neutralization. So you see the spelling differences, right? So they say neutralization normally, but they say neutralization in science. So we see the Z is replaced by an S. First one has Z and second one has S. They are a chemical reaction in which acid and base react with each other. So, like we saw in the previous slide, how the pH value increased when we added a few drops of acid into a container of base. The effect of or activity of an acid is neutralized by a base and vice versa. So, we imagine that you got a bee sting, right? Bee stings are not really good. So, you got a bee sting and the bee sting is formic acid. Formic acid is an acid because of the acid in its name. So, baking soda is a base, right? So, if we apply baking soda solution on the bee sting, it neutralizes. The activity of an acid, like that is the bee sting, contains formic acid and the baking soda, which is a base, they neutralized each other and it gave you some relief. But we'll do the vice versa part. That is the opposite. So instead of a bee sting, imagine if you got a wasp sting. We know all about wasps, right? Wasps are similar to a bee. They have the stinger like bees, but they are a bit longer. And the main difference is that the wasp sting is basic. So baking soda, which is also base, they cannot react with each other because both are bases. So we need an acid to neutralize it. So what do we do now? We have vinegar, right? Vinegar is an acid. So if we apply the vinegar acid onto the base stain, so the acid that neutralizes the base and the base that neutralizes the acid. So the acid and base form salt and water as the products of the reaction along with generation of heat. Neutralization reactions also take place between the acidic proton from the acid and the hydroxyl group of the base to generate water. So that is like a combining of acids and bases. So that is called neutralization reactions. So e.g. in a reaction in water, no excess of hydrogen or something, we can't really read it because I'm there, present in the solution. So we know that two hydrogen atoms and one hydrogen atom makes water. The pH value, the pH of the neutralized solution depends on the, again it's getting covered, the reactants. Experimenting acids and base. So we imagine that we got a white cloth, like in this picture. But when we accidentally spill a bowl of turmeric on the cloth, right? So it's kind of messed up now. So we have two solutions, lemon juice and a soapy solution. So we'll first go with the lemon juice. So if we apply the lemon juice to the stain and nothing happens, this indicates that lemon juice is just an acid. Do you know why that happened? So that happened because we all know that turmeric is a natural indicator that comes from turmeric plants. So it is a natural one. So the lemon juice did not do anything to the turmeric stained cloth because it is an acid. So we'll go with the soapy solution now. When we apply soapy solution, the stain turns red. Do you know why it turned red? We all know that we discussed previously that turmeric is natural. So this indicates that soapy solution is a base. Like the base can do some reactions and acids cannot do some reactions. But remember, those are not only the acids and bases. There are many acids and bases. What are acids and bases? We already covered that topic in the last few slides. But our next question is, why do acids work on bases and bases work on acids? Why is that? So it's because like acids and bases neutralize each other, like we already learned about neutralization reaction in this video. Now we saw that acids can't work over acids and bases cannot work over bases. So they can only work on opposite sides. So we'll take some examples. Do you know what farmers use lime or or just for short calcium oxalate to neutralize acid soils? Yes, friends. So how it works is, like, we know that the soil is too acidic, right? To neutralize the acids and bases, they use that. Do you know what? Your stomach contains hydrochloric acid that breaks down the food you eat. So, and too much of this acid causes acidity. But that is why we need to maintain our hydrochloric acid. Antacid tablets contain bases such as magnesium hydroxide and magnesium carbonate to neutralize the extra acid. Friends, did you notice something? So, anticid tablets has bases in it, right? And then acids are doing the formation. So the acids do the activity and the bases neutralize them. Like we discussed, intestines are a bit painful. So we use acids and bases to neutralize and reduce pain. So we discussed it in the few slides ago. Thank you for watching, friends. I'm so happy that I got to share my learning about neutralization reactions. Thank you, friends. Bye, friends.